Have you ever stared into the night sky and wondered where it all began? Where we came from? A question as old as humanity itself, but one that still holds a certain magic, a certain allure. After all, we are all a little starstruck. The universe, in all its vast and infinite glory, is a marvel to behold. It's a place where galaxies collide, where stars are born and die, where black holes swallow everything in their path. A place of unimaginable beauty and terrifying power. But how did it all get here? How did this magnificent cosmic dance begin? For centuries, this question has captivated the minds of philosophers, scientists, and dreamers alike. It's a question that pushes the boundaries of our understanding, that forces us to look beyond our own small terrestrial existence and reach for the stars. It's a question that has driven us to build telescopes that can see billions of light years away, to send spacecraft to the farthest reaches of our solar system, to study the very fabric of space and time. Understanding the origin of the universe is no mere intellectual curiosity. It's a quest that speaks to something deep within us, a primal need to understand our place in the cosmos. To know where we came from is to know who we are. It's a journey of self-discovery on the grandest of scales. From the ancient cosmologies that saw the universe as a cosmic egg, to the modern theories of quantum mechanics and relativity, our understanding of the universe's origin has evolved dramatically. Yet, despite our best efforts, the question remains, where did it all come from? In the end, perhaps the answer to this question lies not in the stars, but in ourselves, in our relentless pursuit of knowledge, in our boundless capacity for wonder, in our unyielding desire to explore the unknown. For it is in seeking that we find, and in pondering, that we understand. If you've ever pondered these mysteries, you're in good company. From ancient times, humans have been trying to explain the origin of the universe. The inquisitive nature of our species has led to numerous theories, each one a reflection of the culture and understanding of the times when they were conceived. Let's start our journey with the ancient Greeks. They believed in a geocentric model of the universe, with Earth at the center. Their cosmology was intricately linked with their mythology. For instance, they believed that the universe was born from chaos, a primordial void, which also gave birth to the earth, sky, and sea. This theory, while poetic, was limited by their understanding of the cosmos. Now let's travel to ancient China. The Chinese cosmological model was different, yet equally fascinating. They envisioned the universe as an egg. The sky was the round shell, the earth was the yolk, and the space in between was filled with qi, or vital life force. This belief was deeply integrated into their philosophy and way of life. The ancient Indians also had their unique cosmological model. They believed in an infinite cycle of creation, preservation, and destruction, a concept deeply rooted in their religious beliefs. In the Americas, the Mayans depicted the universe as a series of layers, with the earth in the middle. Above and below were 13 heavens and 9 underworlds, each with its inhabitants and gods. Ancient theories, as diverse as they were, shared a common thread. They were all deeply intertwined with the cultural, philosophical, and religious beliefs of their respective societies. These theories were not just attempts to explain the physical world, but also a reflection of how these civilizations perceived their place within the cosmos. These ancient theories, while fascinating, lacked the scientific evidence we have today. However, they laid the groundwork for the questions that we continue to explore. As we delve deeper into our understanding of the universe, we carry with us the curiosity and wonder that sparked these ancient theories. The birth of modern astronomy brought us closer to understanding the universe. This journey began in the 16th century with the revolutionary ideas of Nicholas Copernicus. He dared to challenge the age-old belief that Earth was the center of the universe, proposing instead a heliocentric model where the Earth and other planets orbited the Sun. This idea was groundbreaking. It shifted our perspective, quite literally, and started a new chapter in the understanding of our cosmos. Fast forward to the 17th century, where the baton was passed to Galileo Galilei. Known as the father of observational astronomy, Galileo enhanced the telescope, allowing us to gaze further into the skies than ever before. His observations of celestial bodies like the moons of Jupiter provided further evidence for Copernicus's heliocentric model, sparking controversy and advancement in equal measure. As we step into the 17th century, Johannes Kepler enters the scene. Building upon the work of his predecessors, Kepler devised the laws of planetary motion. His theories described how planets moved in elliptical orbits around the Sun, not perfect circles as previously thought. This was a pivotal moment, providing a more accurate model of our solar system. Finally, we arrive in the 18th century with Sir Isaac Newton, a name synonymous with gravity. Newton's laws of motion and universal gravitation were monumental. They didn't just explain why an apple falls to the ground, they described the invisible force that governed the motion of everything, from the smallest particles to the largest galaxies. Together, these titans of science transformed our understanding of the cosmos. Their theories challenged the status quo, reshaped our worldview, and opened the doors to an era of discovery that continues to this day. From Copernicus's heliocentric model to Newton's laws of gravity, each breakthrough brought us one step closer to deciphering the cosmic code. These discoveries laid the foundation for our current understanding of the universe. And as we continue to explore the cosmos, we stand on the shoulders of these giants ever reaching for the stars. In the 20th century, a revolutionary theory emerged, the Big Bang Theory. The Big Bang Theory is not just an interesting story or a catchy phrase, it's a scientific explanation that has reshaped our understanding of the universe's origin. It posits that the universe started as a singularity, an incredibly dense and hot point, about 13.8 billion years ago. From this intense state, the universe began to expand and cool, giving rise to the cosmos as we know it. But how did this theory emerge? The roots of the Big Bang Theory can be traced back to observations made by astronomer Edwin Hubble in the 1920s. Hubble found that galaxies were moving away from each other, suggesting that the universe was expanding. This discovery led to the logical conclusion that if we were to wind back the cosmic clock, there must have been a point when everything was condensed into a single spot. The evidence supporting the Big Bang Theory is compelling. One of the most significant pieces of evidence is the cosmic microwave background radiation. In the 1960s, astronomers Arno Penzias and Robert Wilson stumbled upon a faint microwave signal that permeated the entire sky. This radiation, the afterglow of the Big Bang, is a relic from a time when the universe was just a few 100,000 years old. Another compelling piece of evidence is the redshift of galaxies. As light from distant galaxies travels towards us, the wavelengths stretch due to the universe's expansion, causing a shift towards the red end of the spectrum. This redshift, observed in galaxies across the universe, provides further proof of the universe's expansion from a singular point. It's important to note that the Big Bang Theory doesn't claim to explain what caused the singularity or what was before it. It merely describes the aftermath of this event, the evolution of the universe from that initial state of extreme density and heat. The Big Bang Theory has become the leading explanation for the universe's origin. It's a testament to the power of scientific inquiry, of looking up at the night sky and daring to ask, how did it all begin? But the story doesn't end there. The universe, it turns out, is expanding. Yes, you heard it right. The universe isn't static. It's not just sitting there, content with its size. It's stretching, growing, and expanding every single moment. This incredible discovery was made in the early 20th century by an astronomer named Edwin Hubble. He observed that distant galaxies were moving away from us, and the farther they were, the faster they were receding. This remarkable observation led to the conclusion that our universe is expanding. Now you might ask, what's causing this expansion? That's where a mysterious entity known as dark energy comes into play. Dark energy is a hypothetical form of energy that permeates all of space and is believed to be the driving force behind the universe's accelerating expansion. It's like a cosmic gas pedal, constantly pressing down, causing the universe to expand at an ever-increasing rate. Yet, dark energy remains one of the biggest enigmas in cosmology. Despite making up approximately 70% of the universe's total energy, it's never been directly observed. Its presence is inferred from the acceleration of the universe's expansion and its effects on the cosmic microwave background radiation. So, what does this mean for the future of the universe? Well, if the expansion continues to accelerate due to dark energy, the universe could end up in what's known as a big freeze. Over unimaginable stretches of time, galaxies will drift apart, stars will burn out, and the universe will become a cold, dark, and desolate place. But let's not end on a gloomy note. The expansion of the universe is a testament to the dynamic and ever-changing nature of the cosmos. It's a reminder that the universe is not a still picture, but a vibrant, evolving entity. As our universe continues to expand, so does our understanding of it. We continue to push the boundaries of our knowledge, to question, to explore, and to wonder, because, in the end, that's what the story of the universe is all about. In recent years, a new theory has emerged that challenges our understanding of the universe, the multiverse theory. This theory proposes that our universe might not be the only one out there. Instead, it suggests that there could be a vast number of universes, each with its own laws of physics, dimensions, and even time. The multiverse theory is a development of quantum mechanics, the branch of physics that deals with the smallest particles in the universe. Quantum mechanics is known for its strange and counterintuitive implications, such as the idea that a particle can be in two places at once. The multiverse theory takes this strangeness to a whole new level, suggesting that every possible event that could happen does happen in a parallel universe. Imagine tossing a coin. In our universe, it lands heads. But according to the multiverse theory, there's another universe where it landed tails. There could be countless other universes too, where the coin landed on its edge, turned into a bird, or even triggered the end of the world. Each universe is like a separate branch on an infinite tree of possibilities. What does this mean for the origin of our universe? Well, if the multiverse theory is correct, our universe could just be one small bubble in an infinite cosmic foam. Each bubble universe could have its own Big Bang, its own timeline, and its own unique set of physical laws. This could explain why our universe seems so finely tuned for life. We just happen to live in one of the universes where the conditions are right. However, the multiverse theory is not without its critics. Some say it's more of a philosophical idea than a scientific one, as it's currently impossible to test. Others argue that it's a cop-out, a way of avoiding the tough questions about why our universe is the way it is. While the multiverse theory is controversial, it represents the cutting edge of cosmology. As we continue to probe the mysteries of the universe, who knows what other mind-boggling ideas we'll uncover? From ancient cosmologies to the Big Bang, the expansion of the universe and the multiverse, we've come a long way in our understanding of the universe's origin. We've navigated through the cosmos, from the philosophical musings of our ancestors to the data-driven theories of today. We've explored the birth of modern astronomy, which provided us with the tools to observe and interpret the cosmos in ways our ancestors couldn't have imagined. We've journeyed through the Big Bang theory, the widely accepted explanation of the universe's birth. This revolutionary theory, backed by substantial scientific evidence, paints a picture of an incredibly hot, dense point, exploding and expanding over billions of years to give rise to the universe we know today. From there, we ventured into the concept of the expanding universe. The notion that the universe is not static, but rather continuously growing, has reshaped our perception of the cosmos. Observations of distant galaxies moving away from us support this idea, suggesting that the universe has been expanding since its inception. Then, we delved into the realm of the multiverse, a theory that proposes the existence of multiple, potentially infinite, universes. This concept, while still in the realm of speculation, opens up new possibilities and questions about the nature of our own universe and existence. However, despite the progress we've made, there are still many unanswered questions. What was there before the Big Bang? What is the true nature of dark matter and dark energy? How does the multiverse theory fit into our current understanding of physics? These are the questions that will guide future research and discoveries. As we move forward, we can expect that new technologies, observations, and theories will continue to shape our understanding of the universe's origin. The mysteries of the universe are far from being fully unraveled, and the journey of discovery is far from over. While we may not have all the answers, the quest to understand our universe's origin continues to inspire and drive scientific discovery.